Good morning students. In the last lecture we discussed the moment of inertia of the uniform rod about an axis passing through its center and one end. Today we are going to discuss another regular body ring and we are going to see the moment of inertia of the ring about different axes. Okay, so we are starting from the moment of inertia of this ring about an axis passing through its center of mass and perpendicular to the plane of ring. So, while deriving this equation for the moment of inertia, we consider a ring of mass m and the radius capital R. So, capital M be the total mass of this ring and capital R be the radius of the ring. Then consider this ring is made up of small numbers of the number of small elements having mass dm, small mass dm. Okay, so first of all we see what is the moment of inertia of this element dm about this axis of rotation, and then we are going to integrate that equation. So what is the moment of inertia of this small element dm about this axis? So according to the definition we can say that the moment of inertia, if we denote this moment of inertia by small I, this small I is equal to, it is integration of r square dm. Okay, it is r square multiplied by dm, where r square is the distance of this small element dm from the axis of rotation and dm is the mass. Okay, so this is the moment of inertia of this small element. Now, if we find out the moment of inertia of whole ring about the same axis, then we can write this equation as the moment of inertia I is equal to this r square, which is the constant, and this is integration of dm, which is equal to m into r square. So what is the integration of dm? Integration of dm is nothing but the total mass of the ring. So we can say I is equal to mr square. So this is the moment of inertia about the center of mass perpendicular to the plane. Now, in the another condition, if we are finding the moment of inertia of the ring but about the diameter, then considering a ring of same mass, same radius, but we are considering here the diameters. Okay, so this is the axis and this is one diameter and this is the second diameter. Okay, so we can write what is the moment of inertia of the ring about the diameter. To find out this equation we need perpendicular axis theorem. So what is the perpendicular axis theorem? Suppose that this is a z axis, this is x and this is y. They all are mutually perpendicular to each other. So the moment of inertia about x axis is equal to moment of inertia about y axis, because the diameter of the ring are same. Therefore, their moment of inertia about the same axis of rotation will also be same. So we can say that Ix, the moment of inertia about x axis, is equal to the moment of inertia of the y axis. According to perpendicular axis theorem, the moment of inertia about the z axis is equal to the sum of moment of inertia about the x axis and y axis. So, by using such type of relation, we can say that this Iz is equal to Ix plus Iy. But we also know this Ix and Iy, they both are same. So, we can write here this Ix as it is plus again Ix. So, which is equal to 2 multiplied by Ix. So, this is the moment of inertia z axis. Therefore, what is the moment of inertia? Ix is equal to, it is equal to Iz divided by 2. But what is Iz equal to? Iz is the moment of inertia passing through the center and perpendicular to the plane, which is nothing but the mr square. So we can write here this mr square divided by 2. So this is Ix, and what is the value of Iy? It is also the same. This Iy is equal to mr square divided by 2. So what is the moment of inertia of the ring about the diameter? It is equal to mr square divided by 2. Now we are moving towards another case, that is the moment of inertia of the ring about the tangent. Okay, so there are two type of tangents. Okay, so consider the tangent and the distance between these two is equal to nothing but the radius of the ring. So what is this? This is the moment of inertia. What is the tangent? How this tangent is connected? This tangent is in the plane of the ring. So if the tangent is in the plane of the ring, then what is this? This is nothing but the diameter. This is the diameter of the ring, and the diameter, the moment of inertia about the diameter, we have already calculated. So in this case, to find out the moment of inertia about this axis, we can find out the moment of inertia by using parallel axis theorem. So according to the parallel axis theorem, what is the moment of inertia? The moment of inertia I0 is equal to IC plus mh square. So what is IC? IC is the moment of inertia about the center of mass, and what is the moment of inertia here? It is equal to moment of inertia about the diameter, which is equal to mr square by 2. So we can write here it is mr square divided by 2 plus this m h square. What is h? H is the distance between two parallel axes, and what is the distance between two parallel axes? It is equal to r square. H square is r square. So what is this? It is 3 by 2 m r square. So this is the moment of inertia of the ring about the tangent in plane. Okay, this is the moment of inertia of the ring about the tangent in plane. So there is another case in which the tangent is now perpendicular to the plane of the ring. So in this case, consider here the same ring. This is the moment of inertia about the center perpendicular to the plane, and this is the tangent which is also perpendicular to the plane of the ring. So how we can calculate the moment of inertia? Again we use here the parallel axis theorem. Okay. So what is the parallel axis theorem? Is I0 is equal to IC plus mh square. What is the IC here? IC means it is the moment of inertia of this ring about an axis perpendicular to its plane, and its value is equal to mr square. So here we can write this mr square plus m h. What is the distance between two parallel axes? It is nothing but the radius, that is r square. So which is equal to twice m r square. So this is the moment of inertia of the ring about the tangent perpendicular to the plane. So in this lecture we discuss the moment of inertia of the ring about the different type of axes. In the first case, the moment of inertia about the axis passing to the center and perpendicular to the plane, which is equal to simply mr square. Then after that we calculate the moment of inertia about the diameter, which is equal to mr square by 2. It becomes 1/2. then the moment of inertia about the tangent in plane is equal to 3 by 2 mr square. And finally, we find out the moment of inertia of the same ring about the tangent, but this tangent is perpendicular to the plane of the ring, and it is equal to twice mr square, which has become twice of the moment of inertia. So in this way, today we discuss the moment of inertia of the ring about the different axis of rotation. In the next lecture, we discuss the another regular body and their moment of inertia about the different axes. This is enough for today. Have a good day. Bye.